talk about 7.1, and what I want to do is go over some terms. In 7.1, you're going to encounter three different terms: a monomial, a binomial, and a trinomial. Now, in a monomial, and launch there, in a monomial, we are going to end up having one term. A term comes up with several different definitions, but in the algebraic sense, basically it is a numerical coefficient, which is a number, attached by multiplication to any amount of variables. So an example would be like 5x, or negative 7x squared y. Or another example would be something like x squared y cubed z. So in these examples, it can be any form of multiplication held together, either other variables with it, with exponents, or a numerical coefficient. A binomial is basically just picking up off of a monomial. A binomial is saying, okay, monomial 1 is bi means 2. So you can't hold it by multiplication because then it would look too much like a monomial. So the binomial is going to be two terms held together by addition or subtraction. So something like x plus 3, or 5x minus 7, or let's say we have 3x squared minus 7y. Any of those examples would be an illustration of what a binomial is. So binomial means two, and they're held together either by addition or subtraction. So plus or minus signs. Trinomial, I think you can guess it at this point, it's the same thing, only there's three terms this time. So the ones we're going to see the most common with a trinomial is going to be something like this: x squared minus 7x plus 8. Or something like this: 5x squared minus 3x plus 5. Something of those type are what you're going to be experiencing as we go through. Now, some important, I would say, habits that we need to get into are going to be listing them. So part of the homework assignment, you're going to notice that they want you to rewrite. So rewriting polynomials. So rewriting them means that we're wanting you to put it in a specific order. So for us, our order is quite simple. We're going to put the biggest exponent first and work our way down. Now, you're going to run into those that have two different variables, like an x squared and a y squared. If you run into that, only one of them gets to be first. So I always say stay alphabetical. So if I have an x squared and a y squared, both in the same polynomial, then you're going to take and just write the x squared first. So here's an example. Let's say we have this. So x, y minus y squared plus 3x squared. And they ask us to rewrite that in order. So in order for the rewrite, so we're going to call that RW, is going to be putting the x squared first, because alphabetically x comes first. So 3x squared, once again it gets to go first because it has the exponent 2, plus, because xy has no sign in front of it, it means it's positive, xy, and then we drop off the y squared on the back. And if you notice, it's kind of like the x squareds are decelerating and the y squareds are accelerating, or getting bigger. So it looks like everything is going to the middle. So x squared to x, y to y squared. So they kind of have a pattern in a sense. So when they ask you to rewrite, that's what we're going to be looking for. So let's just take in the basic term here. So let's just say we have all the same variables. So let's take a step back, in other words. So let's say I have f squared minus 2f plus f to the fourth. So the first step we're going to do to rewrite this is put the biggest exponent first, and our biggest exponent is f to the fourth. It's positive, so I just write it out front. The next one is going to be an f squared. So to illustrate that, we know it's positive because there is no sign in front in saying that it is a positive. And then the last one is going to be a minus 2f. So now we have it written in the correct order. Now this is going to be very important for future sections. So please make sure that when you're doing this, that you always check to see if it's written from greatest to least with your exponents. So let's look at a couple other strange ones. Let's say we have just 3x to the fifth plus 6x to the eighth. In this case, it's just a binomial, but if you look at it for our rewrite, we need to have the eighth first. So 6x to the eighth plus 3x to the fifth. And that's all we have to do to rewrite it. Another concept we need to be aware of is called degree. A degree of a polynomial basically is stating not of temperature, but of the exponents. So when I talk about a degree, let's put an example here. So let's say I have negative 2abc. And in this one, for the degree, we look for the exponents attached to the variables. So it's really important that you understand that when we talk about degrees, we're only talking about the ones that have exponents attached to variables. So in this case, the ABC do not show an exponent, but they have one. It is an invisible 1. So let's show the invisible 1. So I have 3 of them. So the degree for this particular one is going to be 3. Let's look at another one. Let's say that I have 4r squared, s to the third, and t. Once again, we are going to look at the exponents. Now, you notice that these are basically monomials that I'm showing you. So we're going to start off with the conclusion that we look at each term separately to determine the degree. And in this case, this monomial has a 2, a 3, and a t. So you don't pick the biggest one like we did on the first one, we added them. So in this case, we're going to add them. So 2 for the r, 3 for the s, and once again, t has an invisible 1. So our degree for this entire one is 6. Now, if I ask you what is the degree of an overall polynomial, so let's say I have something like this. Oh, let's say I have 2x cubed plus x squared minus 5x plus 12. So we have 4 terms, which makes it a polynomial, because anything over 3 is just called a polynomial at that point. And define the largest. So I'm going to put over here, find the degree of the polynomial. So to find the degree of the polynomial, that means I have to find the biggest one. So we're looking for the biggest degree. Not just any degree, but the biggest degree. So to do that, you look at each one individually. So this one has a degree of 3. This one has a degree of 2. That one has a degree of 1. And since this has no variable whatsoever, we're going to say it has a degree of 0. So this one in particular, the largest degree is going to be 3. So the degree for that polynomial is going to be 3. If you noticed with the 12, I did not put a number attached to it besides a 0, and that is because, once again, it is a constant, not a variable. If there is no variable attached, then there is no degree for it. So we put a 0 just to make sure that we let others know and ourselves that we have already evaluated it and found that it has no variable, so therefore it has no degree. Okay, so this is the first half of 7.1. Let's look at the second half of 7.1. The second half of 7.1 is going to be looking at combining like terms. So this is an exercise we did at the very beginning of the school year. So let's put down a few examples. So let's say I have negative 4x plus 9 plus 6x minus 14. So if you notice, the two sets of parentheses are already held together by addition, which means that there will be no sign change between the two groupings. So there's no reason to have the parentheses, in other words. Now, if this was going to be a story problem, those parentheses may represent a width and a length. They may also be something with radius or with time or distance. So keep in mind that the groupings may stand for something, but in order for us to solve it algebraically, we do not need these parentheses because it has a plus sign between the two. So the first thing we're going to do is line up like terms. Well, I notice I have x's and I have terms without x's. So the x's are both the same degree, so I can combine them. So I'm going to have 6x minus 4x, and I'm going to have this negative 14 and positive 9. As you notice, I kind of mixed them up, but it really doesn't matter because you're going to stack them and combine them to begin with. So this right here is going to be 2x. I have more negatives than positives, and it's opposite sign, so I know I'm going to be subtracting. So when I say combine, keep in mind that means either addition or subtraction, depending upon what the signs tell you to do. So this is a subtraction sign, which means it's a negative 14. So when I take and subtract these two, I'm going to end up with negative 5. So the answer for this particular addition problem is going to be 2x minus 5. Let's look at another one. So let's look at a trinomial. So x squared plus 3x plus 5. Once again, I'm adding the two, and then I have negative x squared plus 6x minus 4. So in this particular example, we have, once again, two groupings representing whatever, either distance or time or length or width, any of those scenarios. So what I'm going to take and do here is I'm going to drop the parentheses since the addition sign is not going to change any signs. So when I line them up, I have x squared plus 3x plus 5, and below it, I'm going to line up the same variables. So the x squared, I'm going to put below the other x squared. The 6x, I'm going to put below the 3x, and the minus 4, I'll put below the one that has no variable. So in this nice little example, the x squareds drop off because I have positive and negative 1. So they drop. This gives me 9x squared because I'm able to add them, and this here we subtract and get plus 1. So in this example, our answer is 9x plus 1. So now let's look at some subtraction problems. So this right here is all addition. So let's talk about subtraction. So let's say I have g minus 4 minus 3g minus 6. Now in this example, it is important that we show the subtraction sign. The parentheses are telling me I'm taking the first term and subtracting it from the second. So in this case, we take and move it across. So I'm going to take and carry this. So this is actually a negative 1 being distributed into each of these terms. So g minus 4, and below this we're going to write negative 3g because I carried the negative 1 through, and then negative 1 times negative 6 makes positive 6. So now that the signs are changed, I rewrote it and lined it up. So negative 3g and positive 1g is negative 2g. Negative 4 and positive 6 is going to give me positive 2. So the difference between those two groupings is going to be negative 2g plus 2. Let's look at a second example. This time let's do a trinomial. So k squared plus 6k cubed minus 4 minus 5k cubed plus 7k minus 3k squared. Now in this particular problem, we have two steps. Let me push this up a little bit. We actually have two steps to do. The first step is going to be write it in descending power order and distribute the negative through. So those two steps have to be accomplished before we even combine anything. So let's go ahead and put my 1 there because we're going to multiply each one by -1. So let's do this one first. It doesn't matter which one you write down first. It just matters about getting them in the proper order and then combining the proper terms together. So cubed comes first. So -5k cubed. Then I'm going to go ahead and do the squared next because the squared would be next numerically. So -1 times -3 is positive 3k squared. And then the last one is going to be combined with the 7, so multiplying -1 times 7 is -7k. Now, we have no number in the back where this one has a constant, this does not. So I'm going to do +0, so I have somewhere to put that 4 when it comes time to combine them. So now let's take and drop the front one down, dropping the parentheses, but I need to line them up. So the cubed should go below the cubed. So I have 6k cubed. Plus, I'm going to go ahead and put a 1 in front of the k squared so we know that it's a 1, even though we don't always see it. We know that if there's a variable there, that it's a numerical coefficient there. The last one, we do not have a k, so therefore we're going to do +0, and then we'll drop down our -4 so that it lines up. So all of them have what I like to call a placeholder. If there is a 0 there, that is a placeholder for something that you do not have. Now, combine my terms on the way down. So I have -5 and +6, so it's going to be 1k cubed. 3 and 1 become +4k squared. The -7k just drops down